So hello everyone, welcome again to my YouTube channel. In the previous video we have discussed about minimization of finite automata, and in today's video we are going to discuss about another technology of minimization, in which we will discuss about Myhill Nerode theorem. So in Myhill Nerode theorem is also used to minimize the finite automata. So in this, let's discuss a few steps. Here it says we have to draw a table of all pairs of states, which consist of P to Q, means we are having A, B, C, D, E states. We will make pair of all the possible transitions. We will draw a table. Basically, a table will look like a matrix. Then we will mark all the pairs that belongs to final state and that doesn't belong to final state. Suppose I am considering a pair for A and D, that is all the transitions between A and D. Then if one of them is final and other one is non-final, I will give a tick mark over there. So if there are any unmarked pairs like P and Q, we will repeat a few steps. In that case, we will check for all the possibilities, which says transition from P with input symbol X, transition from Q with input symbol X. If it is already marked, then we will mark the PQ also, where X is an input symbol. So repeat this until we are no more further marking is possible. At last, we will combine all the unmarked pairs to make them into a single state of minimized DFA. So in this, consider lessons. In this example, to understand this in better way, let's consider an example, and we are considering this diagram of for minimization purpose. So let's solve this with the help of example. So based on that example, firstly what we need to do, we will need to draw a table. So a table will look something like this. As we have seen that there were few states A, B, C, D, E, and in that case we will draw transitions like this. A matrix. So here as we can see, for this diagram this type of table will be there, which is giving certain values. So from here we can say all the diagonal values have been omitted, because for A to A we need nothing, for F to F we need nothing, and similarly for B to B, C to C, D to D, all lies on the diagonal, and above the diagonal we have deleted all the cells because we don't want any repetition, because A to B, B to E, A is one and the same thing. Similarly B to C, C to B, and is one of the same thing. So to avoid repetition we have removed all the cells above the diagonal. So now this column represents A to F, this represents B to E, this column represents pair of C and E, and so on. Fine. So this type of pair we have got in this case. Now as per algorithm we have to check for all the possible pairs. So the first pair is we don't have any A to A, so we will go with B to A. So we will check from this diagram for A and B. So this is B and this one is A. The both are non-final states. We don't mark any, because what was the rule? The rule was for all the pairs P and Q, if either of P or Q is final state, then mark it. If both are final, don't mark. If both are intermediate, then don't mark. We have to mark if one is final and other one is not final. So similarly we will check for this is the column for A and C. Now for A and C, A is non-final, C is a final state. So we will mark over here. Now this pair is B and C. So for B and C, B is non-final, C is final. So we will mark over here. Now for this column, that is DA. From DA, A is non-final, D is final. So we will mark. Similarly, this column is for the value of D and B. So we can see D is non-final, D is final, B is non-final. So mark it. This is D and C. So here we will see both C and D are final states. So we will not mark over here. Similarly for this is for E and A. From E and A, E is final, A is non-final, so mark over here. Similarly for E and B, E is final, B is non-final, so mark here. For and here, C and D, C and E. Among C and E, C is final, E is also final, so don't mark. Similarly for this is for E and D, E is final, D is also final, so dot mark. Similarly for AF pair, so for the pair of A, A and F, both are final, dot mark. B and F, both B is non-final, F is also non-final, dot mark. Now this column is for F and C. So for F and C, F is not final, C is final, mark it. F and D, F is not final, D is final, mark it. Now for E and F, E is final but F is not final, so mark it. So this is the first stage in this case. Now we will go for check for unmarked. So we will try for all the unmarked pairs. So the very first unmarked pair is of B and A. So what we need to do? We need to check for all the transitions for B and 0, for A and 0. It is going to A, it is going to B. Next state is this. Similarly for B with 1, the next state is D. Transition for A to 1, the next state is C. So in this case A and B, or and here is or D and C are not marked, hence we will not mark this stage. Now what is the next unmarked pair? The next unmarked pair is this one, that is D and C. So similarly we will check for transition of D comma 0 to E, D comma 1. Similarly for transition of D with 1, transition of C with 1, it is giving F, it is giving F, it is giving E. For D with 1, here is we are having C with 1, and here D with 1, so it is giving E. The C with 0 is giving E. So here what we will see these are neither of them is unmarked, so we will not mark also. So we will keep on checking for all the states like this, that how we work. So just let's have a look at this. Fine, how the marking is proceeded. So we will check for all the possible pairs. For BF and B we have checked. Similarly for the next marking possibility pair, we will check for all the possible pairs. We will go through the all the iterations in the case, keep checking for the pair of EC, and we will get E with 0 as E, C with 0 as E, similarly E with 1 as F, and C with 1 as F. So when we talk of this pair, we will get no marking required, because these were E and F pair don't exist in this column, in this table, so we can say not existing. Similarly, so we keep on marking until we reach the states. So at the end, when we solve this, we will found a few pairs unmarked. So we will go for the next iteration. We will keep on checking until and unless markings are keep going on. So we keep on marking similar for the next iteration, but after the next iteration we will get like this. All the pairs are marked. So this is marked, this is marked. So this no further marking is possible in this case. So we will stop the exploration over here only. So this is the final stage. Now we have got a few unmarked columns. Make a pair of all the unmarked, and we will merge it like this and draw the diagram of combinations. So that's how Myhill Nerode theorem works for minimization of DFA. So thanks for watching the video. If you need more detailed video on any of the topic, you can write in the comment box. Thanks for watching the video.